Before you start the video, this video aims to evaluate why physics is important, to know and understand the SI units, metric system, English system, and significant figures, and to be able to solve metric system, English system, and significant figures. Now that that's done, let's start the video.
Good day everyone, I am Kian Carlos Elias Budamo. I am from grade 12 Kalinga, and today I will discuss the SI units, the metric system conversion, English system conversion, significant figures, and solving significant figures. So before I start, let me discuss first what is physics and its effects on our everyday life. Physics is one of the most fundamental scientific disciplines. It is a natural science that studies matter, motion, space, time, and energy. We see physics in our everyday life, even without realizing it. For example, we are exercising or even walking. We exert energy that moves us around or that it provides us motion. Measurement takes part in our life since everything has an extent, and some least or more can be bad for us. It helps us measure and understand the things in life. It is related to SI units because SI units are the measurement used in physics, and in order to go furthermore about solving formulas, we must know the units first. SI units, or the International System of Units, is the standard measurement system used in science that comes from the French word system international, the unites. It is composed of 7 units, and from these units arise the derived ones. It's based on scientific fact and tested standards of measurement. For example, these are the length, which is meter, mass, which is a kilogram, time, second, electric current, ampere, temperature, Kelvin, amount of substance, mole, luminous intensity, which is, lastly, candela. Under the SI units is the metric system, which is, this pertains to the prefixes that are used to identify the multiples of 10. The example of these base units is the mass as grams, liters as meter, liquid volume as liter, time as second. Base units can be attached to any prefixes. So as like what I said earlier, we have the mass, which is grams. The prefix would be kilo, and then the mass would be grams. So it will be kilograms. It is something like that. I will show you the procedure and the formula to get the desired amount to help you better understand the topic. So before we go to the examples, we must know the metric conversion charts. So the prefix here we see is tera, that has an exponent of 10 raised to 12, giga, G, 10 raised to 9, mega, M, 10 raised to 6, kilo, K, 10 raised to 3. The base here are the base units that has 0 exponent, or in other words, 10 raised to 0. We got here deci, D, 10 raised to negative 1, centi, C, 10 raised to negative 2, milli, M, 10 raised to negative 3, micro, 10 raised to negative 6, nano, 10 raised to negative 9, and pico, 10 raised to negative 12. So the example that I have is 5 liters, and what is the volume in deciliters? So we have the given of 5 liters, and we will be looking for the deciliters. So first, write the given to the bottom part and the desired amount to the top. It is to cancel out the measurement of the liter to get the desired value. So the output would be 5 liters times deciliter over liter. The next step is we should determine what variable is larger. Since a liter is larger than a deciliter, this means that it will get the number 1. Meanwhile, the smaller measurement gets 10. So it would be 5 liters times 10 deciliter over 1 liter. Now that that's done, we need to find the exponent. To get the exponent, we must minus the exponent of the higher unit and the lower. So this is all based on the metric conversion chart that we have, which is deciliters has the exponent of 10 raised to negative 1, and liter has the exponent of 10 raised to 0. So when we have that, we'll get an equation of the higher or the larger unit would be 0, the exponent, minus negative 1, and the answer would be 1. Now that we have 1, we need to distribute it to the procedure. So the formula would be 5 liters times 10 raised to 1 deciliters divided by 1 raised to 1 liters. Now that the equation is complete, we can convert it into deciliters. So we have here 5 liters times 10 raised to 1 deciliter divided by 1 liter. So cancel out the liters, then we will have the remaining unit, deciliters. So get your calculator ready and simply solve the answer. So 5 times 10 raised to 1 divided by 1 liter would be 50 deciliters. So that's the answer. So the next topic would be English system. It is used when converting it into the US English system or converting it between the US system and the metric system. So here are the examples of the conversion. So we can see 1 foot is equal to 12 inches, 1 yard is equal to 3 feet, and 1 mile is equal to 5,280 feet. The conversion of the units according to the weight is 1 pound is equal to 16 ounces, 1 ton is equal to 2,000 pounds. Now that that's done, let's proceed to the examples. So the first example that I have here is that convert 580 ounces to pounds. So the given is 580 ounces and find the pounds. So we will use the exact same procedure as the metric system, but this time it's already presented, or the value is given, so we just write it down. So 580 ounces times 1 pound is equal to 16 ounces. So just write it down. And so let's write it. 580 ounces times 1 lbs divided by 16 ounces. Cancel out the ounces, so we will have the remaining unit, which is the lbs or pounds. Then solve it with your calculator. So 580 times 1 divided by 16. So we'll have the answer of 36.25. So that will be the answer. 36.25 pounds or lbs. So example number 2. Convert 5 yards to foot or feet. So we have here that 1 yard is equal to 3 feet, and we'll be using that for the procedure. So just same like as the other example, 5 yards times 3 feet divided by 1 yard. It is to cancel out the yard and to have the remaining unit, which is the feet. So we have 5 times 3 divided by 1. So we have a total of 15. So that will be the answer, 15 feet. So significant figures. These are number of digits that have a meaning or contribute to the value of a number. Significant figures can also be called as significant digits. It is reported in a measured quantity, and it indicates the precision of the measuring instrument. Now let's proceed to the rules. Here are the rules of significant figures. Number 1. All non-zero numbers are considered significant. This means that zeros are not considered significant, which proceeds to the example of 1, 2, 4, 5, 6, 7, 8, 4, 5. It has 9 significant figures. 1 non-zero number are considered as one significant figure. Number 2, leading zeros are never significant. As for example, 0.126 only has 3 significant figures because the 0 at the front is not considered as a significant figure. Rule number 3, embedded zeros are always significant. For an example here, 1045, it has 4 significant figures. For the 0 in between the numbers is considered significant. Rule number 4, trailing zeros are only significant if there are a decimal point. As for an example, 454260, it has only 5 significant figures because it doesn't have any decimal and the 0 is not considered as significant. Now that we are done with the significant figures, let's move on to solving significant figures. Solving significant figures. The rule of solving significant figures in addition and subtraction is that it has the same number of decimal places as the measurement with the lowest number of decimal places. In other words, we'll be using the lowest decimal places for us to get the answer. Its rule for multiplication and division is that it has the same number of significant figures as the measurement with the lowest number of significant figures. So, in other words, we will be using the lowest significant figures to figure out the answer. The difference between the two is that addition and subtraction uses the lowest number of decimal places, while multiplication and division uses the lowest number of significant figures. To help you better understand, let's proceed with the examples. As an example for number 1, 116.23566 plus 11.56. To sum up all of that, we will have an answer of 127.79566. But that isn't the least decimal places. So we will get first the least decimal places. So we have here 11.56. The least decimal places is 2 decimal places. So in order to get the answer, we need to cut off the other numbers such as the 566 and round up the last digit. So in order to do that, we will have an answer of 127.80. So we got here the example for subtraction. We have 758.4 minus 125. We will get the answer of 633.4. But since that isn't the least decimal place, we will change it to 633 since 125 is the least decimal place, or it has the least decimal place. Example for division. 155 divided by 5 would be 31. But since 5 has one significant figure, the answer would be 3. Same goes for the multiplication. 555 times 12.5 would be 6,937.5. But since there are only 3 significant figures, the answer would be 694 or 694. That's the end of my discussion, but here's the summary. Remember that SI units are called International System of Units that it's based on scientific facts and it is tested as standard unit for the measurement. Metric conversion are prefixes that are used to identify the multiples of 10. It uses a metric conversion chart. English system conversion is used when converting in the US English system or converting between the US and the metric system. Significant figures are a number of digits that have meaning or contribute to the value of a number. And remember that when you are solving it in subtraction or addition, it uses the least decimal places. Meanwhile, when you use it to solve multiplication and division, it uses least significant figures. Don't forget that physics is important as it provides our daily needs that helps us sustain and live our everyday life. Thank you for watching my video. I hope you liked it. Subscribe to my channel.